for a lot of us, this is going to be the one that drops at the end of the semester, because that one was rough. That was rough for a lot of us. The lowest quiz drops for the semester grade. One quiz. For a lot of us, it's going to be quiz 5. Because that was a adventure. Let's just go with that. So I feel like for a lot of us, we really need to get back in that habit of doing the homework. Because a lot of the questions are just like homework questions. Some of them straight up are homework questions on the quizzes. So not tons, but they're either exactly matched or the same structure. So the homework is not intended as torture. I promise it's helpful. I promise. We pick things very carefully. It's why I don't assign you whole pages. Just on purpose. Okay, so let's get back in the habit of homework because that will help a lot. Remember, I am here Mondays after school and Wednesdays 5th period. You can come and ask questions. You can also take the text line and text me questions anytime. That comes to me. That is not my cell phone number. It is a number, not my number. Just clarify. So, text me, email me, ask questions. I can send you videos that we took. I can send you videos on YouTube. I can send you Khan Academy pages. I can send you many, many resources. Please ask for help. Writing on the quiz, I don't get this, does not let me help you. That doesn't help. That's just complaining, which I get and is valid, but it's not super helpful. What's that?
Leave your names on all the names.
Huh?
Leave your names on.
Then there's the blank pages at the end. You write your name in there. There's blank pages in the back if your name's not on the thing. Okay? So please don't write, I don't get this on the quiz. That does no good for any of us. I'm here. The pink papers have my email, my text line. I'm here Mondays until 3:15, 3:30. Wednesdays during 5th period, anytime. During your study time. Don't skip class. Okay, so let's make sure we look back at some of those things. That one was an adventure. So we're going to move on today. We're going to move on. And so we're going to look at some graphing things. We're going to look at transformations. This was the last page I had up on Friday, so most of us should have this written down. I'm going to show you A, H, K, and B and what they do, and then I'm going to come back to this page and I'm going to draw a little bitty sketch on it. But I'm going to do it on a Desmos graph that has like slideys so we can see what's happening. So, a second. There we go. All right. So I put into Desmos here a square root graph, just because that lets us see what's going on a little bit clearer looking at all the things. So inside, I think this was saved from before I did a thing. Okay, no, I didn't. Okay. Boop, fixing the B. So what I'm going to do is I'm going to go through each of these sliders and we're going to see what's going to happen. That's not what I meant. A little line. Okay. So A, H, and K we have for sure seen before. For sure. We saw this in Algebra 2. A, that's our vertical stretch where it gets taller. It can be our vertical compression where it gets so short and little and cute. And it does our, I'm not trying to get things. Or it can do our vertical reflection, reflect across the x-axis where it can still compress or stretch. So A does lots of things. It does a vertical stretch, a vertical compress, and it can reflect across the x-axis. Stop trying to make them do a thing. I have 1.3 folks now. So H we've seen that's our horizontal transformation, where it shifts things left and right. Stop it. Okay, that's our vertical transformation where it shifts things up and down. So no matter what our K is, it's doing a vertical shift. The one we haven't really seen before is B. And what B does is called a horizontal stretch or compress, or it can do a horizontal reflection. So I'm going to go back to the page that had the big table, and I'm going to use that to kind of give us little sketches to see what's happening here. Because B is a little bit weird, and we treat B a little bit weird. Oh, and I left my stylus. And we're not going to use B tons and tons, but I still want to talk about it. So A, we've seen before. If A is less, that is a weird looking A. Hang on a second. If A is less than 0, so if A is negative, whoa, sorry. If A is negative, that's when it's reflected over our x-axis. Oh, that's this guy. If our A value, the value of A, so the absolute value of A is greater than 1, it's a vertical stretch. So with our little square root guy, stretch makes it really, really tall. Yes, this is 3.5. And a vertical compression, that's if my absolute value of A is less than 1 on a graph, it's going to look like somebody sat on it. Somebody squished it. Because it's just so little and cute, I want to squish it. Compressed. So vertical stretch makes it really, really tall. Vertical compression makes it squished. So that one's a stretch. That one's a compression. So H, that's our horizontal shift. We need to be careful when we're looking at transformation forms. Our X's always have the opposite sign of the expression inside. So I'm going to write our transformation form up here so we can see what I mean. So we're going to have our A. And then we usually have our X minus H. And H has that opposite sign going on there, so it becomes a thing. Our new piece B is out here. And then we do our plus K on the end. This is where our special function will go. So the B is actually outside the X minus H part, but still inside the function. So if this was a quadratic, it would be squared out here. If it was a cubic, it would be cubed out here. It could be our square root here. It could be any of those things. So H, you got to be careful of because our formulas always have a minus H. So if H is less than 0, that's when it shifts left. If H is greater than 0, that's when it shifts right. Just like on a number line. K is very similar. If K is our vertical shift, if K is less than 0, that's when it shifts down. And if K is greater than 0, that's when it shifts up. So a vertical shift up. So our new one and our weird one is B. B deals with horizontals. So it goes with our X. So if B is negative, then this will do a horizontal reflection. So this will reflect over the y-axis. So instead of flipping upside down like A does, it's going to shift it over this way and face it to the left. So that's a reflection over the y-axis. It's a horizontal reflection. And for our horizontal stretch and horizontal compression, it's kind of backwards from A. it works the opposite direction. So if my absolute value of B is less than 1, so if it's small, it's going to be a horizontal stretch. It works backwards. Because if you think about my vertical stretch, that's when I grab my function and stretch it up tall. I'm going to grab my function and stretch. So my square root would look more like, trying to get it, horizontal stretch goes that way. I'm going to just go to the graph and double check because B is stored. So if B is little, see what's happening? It's stretching that way. Stop trying to make me open a window. So as B gets smaller, it stretches that way. So it looks like when we stretch, but it's just like squished. So B's default state is kind of a 1. And if it's little, it goes that way. So if B is bigger than 1, it looks like when we do a vertical stretch, but it's actually a horizontal compression. So if B, the absolute value of B is greater than 1, then it's a horizontal compression. And it looks like somebody kind of sat on it from the side. So it gets like that. Again, we're not going to see B tons and tons and tons. I'm going to show you how to deal with it once we get to them. For the most part, we're going to have A's, H's, and K's. Like normal. But occasionally we'll see a B, and I will show you what to do with it when we get to it, okay? So for our B's, the B needs to be inside our special function, but outside the x minus h. Okay. Questions on any of these pieces? Okay. Because what we're going to do today is we are going to graph a bunch of stuff. A bunch. Okay? Because that's what 3-5 is. It's all about graphing. We're going to graph all these different kinds of functions in 3-5. So, that's my link to my slider graph. So we're going to start with the parabola. Familiar. I have up here, if you want it, something that you can use if you are not super comfortable with pulling up parent functions from your brain. This is a page that'll help you practice that. This just goes through our parent functions, but you don't have to do it. So I'm going to put it up here if you want to have it. But I'm going to walk you through our parent functions today. But if you want to have that for like homework and stuff, you can have it. Okay? I was just putting it out of my way. So I'm going to pass you guys out some graphs. I'm going to put out numbered graphs and unnumbered graphs. You can use whichever ones you like. The ones on my screen are the unnumbered. I did them in my notes with the numbered, so it fits on them. Both of them. So I'm going to put out some of each. You guys can use whichever one you want. We are going to do a bunch of graphs. And if you guys also want to use these for your homework, that's totally fine. I have questions, like this is not even my entire staff on my graphs. But there will be a lot of graphing on the 3-5 homework. When we are proper graphing, it needs to be graphed on a grid, whether you use mine or graph paper or any other combination of it's fine for me. But it needs to be properly graphed, not given a sketch on a freehand.
I'm actually 2096. Could you give us one of those, please? Thank you, both of us.
I got you. I was like, I made plenty. Yeah.
Yes, this is what I'm talking about. Cheats.
No, we don't get a reference page.
Not even a little notebook, like a little notepad like in college.
No. You said no.
IU pisses me off. That's why I'm not going there. They are not getting my money.
So, yeah, I get that, valid. But yeah, they said that we don't get to have that. So, sorry. I mean, at least this semester we don't have tons of formulas. Next semester is a lot of formulas.
I'm excited for the circle.
The unit circle?
Because there's so many people.
There's so many different things. I will show you the ways through it, but like it's a lot, and there's a lot of formulas to memorize next semester.
The circle, right?
Huh?
The circle.
The unit quiz, yeah, the unit circle.
Yeah, we are.
We do that. I think we have it scheduled 4 times, and it is pass fail. Like it is perfect or it is 0. But you get 4 tries on it in class, and you have 3 minutes.
Never gotten an A on a quiz.
A unit circle, it is perfect or it's not. But it doesn't change. Like it's not different questions. It's the same thing. You just like fill it in. It's 3 minutes. I mean, regular pre-cal gets 4 minutes, but the regular. No, I don't get it.
Oh my goodness. I'd rather have that one.
All right. So what we're gonna do is we're gonna start by identifying our A, H, and K. We'll get B out when we need to, but A, H, and K we use pretty much every time, whether it's there or whether it's not. And I'm gonna graph this in transformation form because that works with pretty much all of our functions that we're working with, using our A, H, and K tables. The way I build my tables might not be the way that you build your tables, which might not be even the way that you were shown to build your tables. Do what works for you. I promise we'll get there when we get there. So first thing I want to know is, do we have A, H, or K here? What is our A value? -1/2, which means what's our transformation? Compressed. And reflected over the x-axis. So we're being specific. It's over the x-axis because we saw that B is how it reflects over the y-axis. So what is the H value here? 0. What is our K value here? 0. When we're graphing in our transformation form using our A, H, and K, that's when we put our parent table, where we pick our x's to find our y's. Our parent table for quadratics, that's our y equals x squared. It has no A, no H, no K. For our parent table, we always take that good view of the middle, and we're going to usually use -2, -1, 0, 1, and 2. For x squareds, we usually use those 5 because it gives us the best view of the center. That is not law, it is just habit. So that's going to give us y values of our parent of what? Parent being y equals x squared. Careful. 4, 1, 0, 1, 4. So you don't have to graph your parent function. I'm just going to sketch it up here real quick so that you guys see what it looks like. So I'm just going to put a little sketchy sketch of it. So it looks, boop, boop. So this is our parent. Parabola. That's what they kind of look like. You don't have to sketch the parent on there. This is going to be the only one I put it on. It'll be the first one for each function just so we can remember what they look like. To get our transformations, I'm going to make my table wider. So I build my table like this. If you do them as 2 separate tables, that's fine. If you do it as an outside to inside, that's fine. I do mine inside to outside. Just feels like it makes my screen more organized and run out of space. So that's all it is. So you can build your tables however works for you. I'm going to put my x plus h on the left and ya plus k on the right. This is how we did these in Algebra 2. Your table may look different, but we used this process when graphing from transformation form. So we take our x values from our parent table, and we're going to add our h. In this case, my h is 0, so they're not going to change even a little bit. So negative 2 plus 0 is negative 2. Negative 1 plus 0 is negative 1. 0 plus 0, 0. 1 and 2. For the right-hand side, we're going to take our y values from our parent table times our a. So we're going to go times negative 1/2 here, plus our k, plus 0. So I take my y's from my parent function times my a. So 4 times negative 1/2 is going to be what? If I take my 4 times my negative 1/2, negative 2. 1 times negative 1/2. What's 1 times negative 1/2, y'all?
That's hard. Let me. Oh, right.
How about 0 times negative 1/2? 0. 1 times negative 1/2 is negative 1/2. And 4 times negative 1/2 is 2. So when we're plotting these up, if you build your table like mine, you're doing our leftist piece to our rightist point. So my first point is at negative 2, negative 2. So negative 2, negative 2. Then we have negative 1, negative 1/2. 0, 0. What's up? Say that again. I just physically couldn't hear you. Oh, yes, the bottom one should also be a negative 2. Here, nope, you're right. I just was writing and talking at the same time, so I'm not always great at catching all the pieces. So we've got our points. So we're going to connect it up, and it's going to look kind of like that. You do not have to graph the parent function. Because honestly, a lot of our parent functions wind up being kind of gross later on. So I just did that so we remembered what that looked like on this first one. I'm not going to do it for any other parabolas to put the parent function on there. So whenever I change functions, I'll sketch the parent function in just so you can remember what they look like normally. Because this one, we can look at our transformations that we said. We said this was going to be compressed, so it has been squished. It looks kind of like somebody sat on it. So it's got that vertical compression. And it was reflected across our x-axis because it faces upside down. So looking back at your AHK to see what our transformations are actually really can let you spot check your graph and make sure that it is doing what you expected it to do. Questions on this first one? Cuckoo. Boop. Another one. This should again be really familiar from Algebra 2. We've done these.
This is the basic.
This is the basics.
Uh-huh.
This is review.
This is review. You did this in Algebra 2. I promise.
And then fail. Actually, no, I didn't. But...
You did not, or you would not be in here.
Oh. Isn't this one?
If I throw it, I feel like I would make it.
Hey, throw it, and you're gonna get it. Guess what?
Oh, thank you.
I remember. Well, I think that's
Oh.
Yeah, but I got glasses.
right.
Don't throw. Don't throw.
Right. Oh my God, one time we were big idea for this class. He got so.
I only had
No, Mr. Yukote is to the next level.
All right.
I was like,
So let's find our pieces here. What is my A? 2. What is my H?
yeah, oh my god.
3. Good. What's my K? 0. So on this one, our parent function is still the same. This is still an x squared. So my parent function is going to be exactly the same. We still take that good view of the center at our negative 2, negative 1, 0, 1, and 2. Again, picking these 5 is not mathematical law. It's just the easiest options because if we pick any further out, we risk them being off our graph by a lot. Our parent function is still the exact same as the last one, so we're going to have our 41014. I'm going to expand my little table so that I can do my transformations. So again, I take my x plus h. So in this case, I'm going to take my parent function x's, and we're going to add 3. So if I take my parent function x's and add 3, what are we going to wind up with over here? Negative 2 plus 3, 1, and then 2, and then 3, and then 4, and then 5. Doing these with transformation form is genuinely, calculatorily, since we don't calculators, a lot easier than trying to do it any other way. So putting these into transformation form is going to be the easy option for us. So now we're going to take our y's times our a. Y times a plus k. If we struggle with that, remember that graphing makes us yak. YA plus K. Yeah. So we take our y's from our parent function. We're going to go times our A, so times 2 plus our K, which was 0. So we've got our 4 times 2. What's 4 times 2? 8 plus 0 is just 8. 1 times 2. 0 times 2. 1 times 2. And 4 times 2. 8. All right, so plotting our points. On the numbered graphs, our first point's going to be slightly off, but if you have an unnumbered one, it will fit, but just barely. But either way, it's just slightly off the graph. It's not a huge amount. We can eyeball that. 2, 2. 3, 0. 4, 2, 5, 8. So if you have the unnumbered graphs, I'm just going to change the view here for a second. So if you use graphs that are just like slightly the wrong size, so like we had our 1, 8. So if our graph was here and it stopped, I could just put my arrow up here saying, I know there's a point up there right by when I get to 1. And I know there's a point up here when I get to 5. So it's way up there, it's off my graph. So that's a way to kind of sketch it in. If I know it's off my graph, that'll still let me get my graph pretty and on point when we're looking to read, because then we can connect this like this. And when I zoom out and go back to my 10 by 10 graph, it's still lining up properly. So I could just then connect this up here and it just works exactly the same. Okay, so when you have a graph that doesn't quite fit, put an arrow pointing to the point that you can't quite reach, and it'll get you there. Okay? So we don't necessarily have to have graphs where every single point we pick shows up on the graph. I have plenty of graph, and I can always print you out some graph paper if you just like sheet of graph paper. So just do what we can, okay? So something I want to talk real quick on this one before we look at our next one. We didn't talk it on the last one, but what's our domain for this function?
3.
So our domain, I heard someone say it as all real numbers. How far, so as an interval, we'd put this as from negative infinity to positive infinity. It's how far left, how far right. Our range goes from 0 to infinity. 0 is when we have our square bracket. It's how far up, how far down. Smallest to biggest. The lowest this goes is 0. The highest this goes is as big as I can imagine. So if you write this algebraically, it would be my y's have to be greater than 0. But we are going to stick with interval notation, though I will take all real numbers for the negative infinity to positive infinity. That's fine. They mean the same thing. Okay. questions on either of these two? Because we have a new thing we haven't seen yet.
B?
We're going to have a B.
I don't like B.
B is inside our transformation point. So, I'm showing you right now. So the way this shows up, our A, since this is a quadratic, it would be B x minus h squared plus k. So my A is still out front. Same thing out here. My h would still be inside in the x. B is multiplied, but still inside our exponent thing. And then our k is added on the end. So we'll start with the easy ones. What's my A? 1. What's my H? 0. H is added and subtracted. What's my K? 3. And then what's my B? 1/4. So we're still going to set up our exact same way. I'm going to put my parent function in the middle. I'm just going to make this long to begin with because I'm tired of the... I'm just going to make this big to begin with. So this is my parent. It's still my y equals... What is that y? Y equals x squared, where we have our -2, -1, 0, 1, and 2 with my 4, 1, 0, 1, 4. Still that same parent function because it's an x squared. When I go to do my transformations, we're still going to have our yak on the right-hand side, y times a plus k. And on the left side, we're still going to use our x plus h. It's just going to get a friend. And it's, if we think about B doing the opposite of what we expected, because when we looked at its instructions and I had the little numbers, we're doing a stretch, and the big numbers did a compress. So we're going to actually take 1 over B times our x. So it's the inverse of B, x plus h, y times a plus k. Because B does opposite things, so we flip B on its head, because he does weird stuff. Other than that, same process. So we're going to take our x's from our parent function times 1 over b. What is 1 over 1/4? 1 over 1/4. So remember, when we divide, it's the same as multiplying by the reciprocal, right? 1 times the reciprocal of the bottom. 4 over 1. So 1 divided by 1/4 is going to be what?
4.
4. So x times 4 plus h, which my h is 0 here, so. So that 1 over b is what really will throw the wrench at it, okay? So I recommend writing it up here with it not being a 1 over fraction. So if your b is little, switch it so that you multiply by the reciprocal. So then we take our x's from our parent function, so -2 times 4, which gives me -8 plus 0. -1 times 4 gives me -4. 0 times 4 gives me 0. 1 times 4 gives me 4. And 2 times 4 gives me 8. Our ya plus k is the exact same deal. So I take my y's times my a, which is 1, plus my k plus 3. So my first point here is going to be 7, and then 4, and then 3, and then 4, and then 7. So when we plot up our points, we're going to have our -8, 7, which I know is slightly off the numbered graphs, -4, +4, 0, 3, 4, 4. Oh, my 0, 3 is too low. There we go, 0, 3. And 8, 7. So a horizontal stretch looks a lot like a vertical compression. Okay? So again, B is not going to come up tons, but it will a little bit. What's up? Thursday. Huh? Thursday. Yeah. This stuff. Uh-huh. All right, let's do one more graph. This one's a different parent function, though. Doesn't change what we do. We're going to look at an absolute value for this one. And then tomorrow, we're just going to, like, graph beginning to end. Just keep going with different functions. Because we're going to get through all those functions that were on that list. So today, we're going to do our quadratic, and we're hitting an absolute value here. So what's our A here? 1. What's our H? 5. And what's our K? -4. We don't have a B in here, so I'm not going to write it if we don't have it because B's are weird and gross. So this one's going to have a new parent function. I still want to pick that good view of the middle, my -2, -1, 0, 1, and 2. But what are my y values for my absolute value parent function? So we're going to have our 2, 1, 0. What were the last two? 1 and 2. They're absolute values. The absolute value of -2 is +2. The absolute value of +2 is also +2. How far are they from 0? So then we're going to... You seriously did not die over the weekend? Stupid fly. He's been in my room since Tuesday of last week, and it is so big the screen thinks I write on it when he lands on it. It's a big fly. It thinks it's a finger when it lands on the screen because it's that big. It's a giant fly. The fly flying around is so big. All right, so we're still going to do our x plus h. So I'm going to take my x values from my parent function, and we're going to add 5. So what are my new x values? 3, 4, 5, 6, 7. And if you have the numbered graphs, that one will be slightly off, but that's okay. We have enough information. So again, with our y side, we remember graphing makes us yak, y times a plus k. So I'm going to take my y values times my a, which is 1, plus my k, which is -4. So plus -4 is -4. So what are my y values going to be? -2, -3, -4,
It's the same process.
-3. Same exact process. It's just the parent function that's different. The process is 100% the same for every function we're going to do. It's just the parent table that changes. So the process is the same. So then we're going to graph those outsidey points. So I have my 3, -2, 4, -3, 5, -4, 6, -3, 7, -2. And when we are graphing things like absolute values or lines, please use a straight edge of some sort. If you don't have one, I have several. Also, when we're graphing, go to the edge of your graph paper. Do not give me that. Don't give me that. Go to the edge. Hit the wall. Go until you hit a wall. Fill the graphs you have. Do not give me teeny tiny little baby lines and expect me to read your minds. Okay, I'm going to put up homework for 3-5's numbers so that you have it. You're going to need graph paper. You're going to need graph paper.
Do you have like graph paper?
I
Or
have
just graphs on paper?
I have graphs on paper. I can print you the graph paper if you want, but I have single graphs, I have sheets of graphs, I have graphs on paper. I have lots of graphs available. Choose size. Choose your size.
Can you please have a graph paper?
Yeah, I'll print out
Need to
some.
get
I'll
this.
have free more.
Thanks.
You actually use it?
Yeah, I don't know how to do comparison. I only just memorize it. I don't actually.
Did everybody get a chance to sign the clipboard? Colton, did you get it? Colton,
That the B is-
did the clipboard?
Yeah, I did.
Okay, cool. And then the three of you guys, Herbie,
That the B is.
you guys signed the clipboard. Herbie, did you sign the clipboard? Okay.
Carson, it was funny in the moment.
Did you see what I
And I told you to shut up, turkeys.
Yeah.
Because you're a
You
turkey.
need to listen to what I said.
They're really
Exactly.